Good morning, good afternoon, everyone, and welcome to our presentation. The main focus of this presentation is VSIG building, which we have done as a part of our Masters in Global BIM Management at Zigurat Global Institute of Technology. As a part of the Global BIM Management program, we, the BIM SCUT team, have applied our complete BIM knowledge to the VSIG building as shown here. Before we jump into the details, let me introduce our team. Sean was the BIM coordinator for the design and construction stages of the VSIG building, and Simon was the BIM manager for the entire process. I was the architectural manager at the design stage and the BIM coordinator at the construction stage. Then Osama was the design phase structural manager and construction phase MEP manager. Ayodele was our MEP manager at the design stage and structural manager at the construction stage. Jessica acted as the BIM coordinator for the design and the architectural manager for the construction. As shown, our main strength was our globally diversified team. It brought many advantages throughout the process. So let's dig into more detail.
Phase 1 Pre-tender. At pre-tender stage, before the contract was agreed, BIM Execution Plan (BEP) was developed with the aim of demonstrating the proposed approach, capability, capacity, and competence to meet the exchange information requirements (EIR) in general terms. Upon the award of the contract, a further detailed BEP was developed to outline the information management of the VSIG building project. BIM Execution Plan. The focus of post-contract BEP document is to confirm the supply chain's capabilities by understanding and establishing a framework that outlines key elements such as strategy, process, information, infrastructure, personnel, and standard. BIM uses were identified based on the outlined project goals. BEP covers the appointment from the conceptual phase to operations phase. Elements under each discipline model were detailed as per information exchange requirements. For the task commencement, a mobilization process was deployed before the production of any information. A stipulated time frame was outlined for each delivery milestone according to the projection in the work program schedule. Roles, responsibilities, and approval process for first setup and second setup of project team was produced to further work on key deliverables of individuals and as a team. Common data environment. The components of the CDE includes information states, classification of information containers, revision control, and permitted level of information access. A master information delivery plan was set out based on a series of individual tasks. Each information container has a unique ID based upon the documented convention. Clash matrix and rule set. To make quick decisions on which elements of a particular discipline should adapt to another discipline in clash cases, clash matrix was developed. Clash detection and collaboration. Issues were created upon clash detection with visual representation and description that includes naming, responsible party, and priority. Issues were synchronized and managed in cloud.
Phase 2 Design. Design authoring for design and pre-construction phase of the VSIG project. Being one of the BIM users required by the appointing party in the EIR, and due to the interoperability and collaborative nature of BIM, we deployed different BIM authoring tools such as ArchiCAD and Revit to author parametric models for 2D documentation and 3D detailing of architectural, services, and structural discipline. Starting with the initial architectural model, each discipline developed their design model. Information exchange between the discipline task teams happened within the CDE, BIM Sync. The required model information and project data contained within each discipline model were compared with the BEP requirement for project information modeling and asset delivery. The values added by these to our clients include improved communication of design intent, improved quality control methods, and powerful design visualization and true collaboration. Design authoring was a mainstay of our coordination and clash detection process.
Now let's take a look at the pre-construction phase. In this phase, we carried out the design authoring of the facility. Once detailed models were completed, IFC models were validated and clash detected before uploading final versions to the CDE. Approved models were used to generate model uses as specified in the information requirement. Let's take a look at some of these uses. First, let's take a look at the visual communication. Federated IFC models were first exported as DataSmith format to be uploaded into Twinmotion. The general context was created by assigning texture, environmental conditions and contextual models. And then, narrative was established by setting frames for images, videos, and panoramas. Media was then exported for presentation via native files or presentation to cloud. The following is an example. And now let's take a look at cost estimation. First, the MDR requirements were received from the clients, and then imported IFC to Celebri. Classification was assigned, and takeoffs were generated. Pivot chart tables, as well as filters and selection, were created in Excel and exported for further use. The following is a real-time conceptual model with quantity takeoff for comparison. Now let's take a look at construction scheduling. First, the models were imported into Synchro. Resources were assigned, and resources were managed by adding appearance profiles, setting calendar dates, and adding activity codes. Tasks were managed by first being assigned and then assigning resources to tasks. Duration and key dates were set, cost assigned, and 4D linking was undertaken. Sequences were visually managed and tested along a Gantt chart. And finally, custom filters were assigned to trades for accessing planning content. And media content was exported to illustrate the construction process. Now let's take a look at the energy analysis. First, the IFC was imported into Revit. The input energy settings were then managed. An energy model was then generated in Revit. A report was generated using Green Building Studio. Finally, energy saving strategies were developed. And finally, let's take a look at structural analysis. In this process, IFC generated from Revit was imported into SIA. Here, structural elements and materials were mapped to SIA recognized values, and solid elements converted into 1D and 2D SIA elements. Next, resistance rating and load-bearing statuses were assigned to structural elements. A report was then generated which analyzed internal forces and deformation of structural elements. The final model was then exported to Tekla for further use.
Phase 4. Asset Operations Management. To make a successful handover, we will not only focus on what we are delivering at the right hand, but also thinking through how to maximize using our BIM model to support the client to navigate the information in the fast-track way. So we introduced two outputs from our model, which is our COBie spreadsheets and IFC virtual dashboards. To generate a complete COBie spreadsheets, as we can see in the flowchart, the native model to be loaded that require COBie metadata by the COBie tools for Revit, assigning unit class classifications by using classification managers in Revit, using product datasheets to capture specifications and store them in the CDE platform, capture room data as per EAR required in our BIM model, final outputs using the COBie QC checker before handover. For IFC virtual dashboard, we are treating the IFC model as a data source that can be used to generate a virtual dashboard using Power BI. The dashboard contains COBie data, IFC data, and Revit data. Here are some quick screen grab and videos to show what we are delivering. On the left hand side, it shows capturing the raw product data, room data, graphical model, and preview of the COBie spreadsheet that what we have done. Right hand is what we have produced, the Power BI virtual dashboard, which allows the client to use and navigate freely without actual cost input.
Now with the Phase 5 implementation. To conclude, this is where the project went through all the stages. We had to plan how everything is going to be done so we can guarantee smooth workflow and collaborative production. Starting with communication, we have used Slack for our daily chat, communicating ideas and meetings. Alongside, we have adopted agile project management methodology where we considered every stage as an iteration. We have our products as tasks and we use Trello boards to plan and organize that. One of the benefits of doing so is that we have our retrospective meetings, so we keep enhancing the whole process. Along the way, we run our self-assessment by doing SWOT analysis to know where we stand as a team implementing BIM. Then, moving on as a multidisciplinary organization, we have started with the golden circle to define why to implement, how to implement, and what to do to implement BIM. Finally, we came up with our BIM implementation roadmap. We then established our BIM capabilities. Then we have created our own BIM audit and performance metrics.